Alright, folks, this is the last new topic for the first unit in integrated science, and it's all about significant figures, or, as I like to call them, Sig Figs. Now, your book refers to these as significant digits. I generally refer to them as significant figures or sig figs because it just rolls off the tongue. Either way is fine. So we're talking about the same thing here. Now, what I did is on the side of the page, I listed out the numbers that are significant when you're making a measurement and the numbers that are not significant. And keep in mind, sig figs improve the precision of a measurement. So how close values are to one another. Now, the closer they are, the more reliable the measurement is. And certain instruments just can't measure that accurately, or that precisely, I should say. And so we need to keep that in mind when we're actually making measurements. Our measurements are only as precise as the instruments that we use to measure them. So, here are the rules at the left. Non-zero digits are always significant. So if it's not a zero, it counts as a sig fig automatically. Now, zeros at the end of a number with a decimal point are always significant as well because they make the measurement more precise. So for instance, if I had 5.2, that would have 2 sig figs. And if I had a measurement of 5.200, which we can measure on some of our balances, so let's say we had a measurement of 5.200 grams. That measurement would actually have 4 significant figures. And I know this is sort of counterintuitive because it almost seems like the zeros at the end don't need to be there. But in reality, they do make that measurement more precise. We know for certain that those 2 digits are zeros. And so that's a more reliable, more precise measurement than simply 5.2 grams. So, again, zeros at the end of a number with a decimal point are significant. So if we had 5.200000000, all those zeros at the end would be significant. Now, the other rule is that zeros between non-zero digits are going to be significant. So if I have 5,0,0,0,0,0,2, all of those zeros that are in between 2 non-zeros are significant. If you surround them with non-zeros, they have to be significant. So we have 1, 2, 3, 4, 5, 6, 7 significant figures there. Now, if we had 5,0,0,0,0,0, so I'll just write that down here. 5,0,0,0,0,0,0. 0. So now we've got the difference between 5 million and 5,000,002. 5,000,002 being a more precise measurement because we know that it is 5,000,002 has 7 significant figures. If we have a measurement that is simply 5,000,000, then we're not sure if it's slightly more than 5,000,000, slightly less than 5,000,000. We just know it's around 5,000,000. Now, all of those zeros, all of these right here, they're important to understand how big the number is. They tell us the magnitude of that number. They tell us that it's 5,000,000 and not 5. So they are important for us to understand how big that measurement is. But they don't make the measurement more precise. In fact, it kind of seems like a number that you would round to. So, zeros that are placeholders at the end of a number without a decimal point, like the one we have here, they are not significant. So, that measurement has exactly 1 significant figure. And I know that's totally counterintuitive because you need those zeros to make sure you understand that that number is 5,000,000. But, again, we're all about precision here. And that measurement is kind of a rounded measurement. The one above it, 5,000,002, we know specifically that it is 5,000,002. So, another example would be if we have a number with a decimal point, like this, 0.000052. That number, just like in the example you see to the left, has 2 significant figures. Only the 2 non-zeros. Again, we need those zeros to understand that this is a very small measurement. However, only the two numbers at the end, which are not zeros, tell us precisely what that measurement is. So the other ones don't allow us to measure any more precisely, so they are not significant. Again, this is difficult to wrap your head around sometimes, but as long as you follow these rules that are on the left-hand side of the page here, you should be able to get the hang of sig figs before too long. So good luck with it. Thanks.